You're able to see my screen?
Yes, I can see.
Yes, we can see.
So now, today we are going to talk about how to generate the SQL script automatically by using the entity objects configuration and mapping. So here I'm going over the test, source test Java. So because this is whatever the script generation and everything, you don't need to keep in the mainline code. That's why I'm keeping in the test folder. Not here. I think there is a library here, right? Okay, new package. I'm creating the package on the test folder. Prior had whatever the main package you see right on the main line. So I'm keeping the same package. And I'm just adding one more, the util package. So where we are going to create the class file to generate. I'm just mentioning here as Hibernate schema export. I'm just creating my own class. So now here, I already have that class. So this is a temporary class. Temporary class in the sense, this won't need to be keep in your mainline code because it's not dealing with any of your business logic or anything like that. It's just used to generate your, script. So I'll show you this one. Let's see. I'm copying all the code from my previous project, but I'll explain you how that works. Okay. So now, what is this layout called? This is also not there. Improved naming strategy. I'll explain you. Don't worry about what I have typed in. So now what I did is I have created my own class and which has the main method, meaning I'm creating a standalone class. So just having a main method. Whenever you have a main method, you can do right click, run as Java application. When you do like this, what it does is it will pick up the main method. Main method is the entry point to execute any of the class. So because we have a main method, the main method will get executed from here. So now let's come to the main method, how it is. So this is a pretty standard way of generating the Hibernate schema, the SQL schema. What I'm doing here is creating this is Hibernate specific stuff. So standard service registry builder, and then here, this line is very important. So what here I'm doing, I'm saying, use the Hibernate direct and generate SQL script based on MySQL database. So if you're using Oracle, this line will get changed to use Oracle dialect. So to get to know, you need to search in Google and figure out what is the Oracle dialect for Hibernate configuration. So whatever you get, you just copy here. So because we are using MySQL, I'm having MySQL dialect. So that's the first step. And the second thing is what are all the classes to be or entities to be considered to generate SQL script for MySQL for dialect. It is nothing but this line. I'm configuring all the sources. So whatever here, right, SSRB, this is my object, and passing the SSRB.build as a metadata. So, and then I'm keeping all my objects into metadata configuration, this line. So here, file user entity.
Sorry, what is that metadata source for?
So this is Hibernate thing. So whatever you keep the entities into the metadata source, it will take all the classes. So this is a metadata data source object, Hibernate specific one. So for this object, we are passing all entities. So for now, I have only one entity I am passing. So I don't need to keep the table name also. I am removing the table name now. Earlier, I showed you with table name, hardcode mapping, and everything. I don't need to keep anything. Just create your entities. And here also, I am removing all the class names, all these hardcode names. You don't need to mention column names and all this stuff. So right now, I have just created my entity with first name, last name. That's all. Nothing is there here. Now come to here. I am adding the entity class. File user is our entity class. I'm keeping only one entity class into the metadata sources. Now, once you have that, so these are all pretty standard Hibernate specific stuff. What it does is, if you see here, configuration object, and these are all the Hibernate provides the different implementations available with configuration object, and take the builder and metadata builder and apply all. So this one is very important. This is the JPA specification. We are applying on the builder JPA specification, and how do you want to generate your table names and everything? So that is nothing but this line. Apply physical naming strategy. How do you want to generate the table names? So now this is where I have created my own custom naming strategy. That's what the class this is. I'll show you how this is. Okay, so for all these overridden implementation, I'm just keeping only one method implementation everywhere. So these are all the methods coming from physical naming strategy. This is again Hibernate specific interface. Because you are implementing Hibernate specific interface, these are all methods needs to be overridden because these are all coming from the physical naming strategy interface. So now this one, for all those implementation naming strategies, I'm keeping the same implementation name. So now you see here this dot convert name and everything, right? String utility size. What is this case format? From where the case format comes? I'm using the Google. Okay. So here, case format is the class available in, this is an open source API provided by Google, which is having the free implementations for multiple things. In our example, we are using for only case format, but this generally has a lot of other utilities that which you don't need to write yourself again. See here, what is happening here? If identifier is null, don't do anything. Meaning identifier means table name, whatever the table name. If the table name is available, then do convert the upper camel case, something like this. Let's say you're using, your table name is something like this. Your entity class is something like this now. So this meaning, the line number 42 meaning, generate class a table name as this for your user. That is a camel case structure. Let's say you're doing a prio address name, something like this. Let's say if your entity name is something like this. So every capital case, the first one is prio. After that, every uppercase letter, where A is an uppercase letter, then immediately you keep underscore address. And the next one is N is a capital case, underscore name. This is how the table names will be generated. I'll show you how that will generate also. So that's the meaning of line number 42. Okay, and why this is... So this class defines how we are going to generate, column names or table names and all that stuff. Just like I explained, right? That's the meaning of upper camel case. This is what upper camel case. And how do you want to keep wherever the camel case letter comes? Keep lower underscore. That's why you see that underscore comes into the game. So now let's see how this will generate.
What are all those methods for?
Which one?
The identifier to physical catalog name, schema name, table name.
Where is the table name here? You don't have any table name here, right?
No. All these methods, what are those used for?
So these are all used for how do you want to change, for every damn thing. Schema name, how do you want to use? Physical sequence name, how do you want to use? Column name, how do you want to use? See, these are all the minimum implementations are coming from this interface. So what I'm doing is, whatever they want, everywhere I'm saying that use camel case structure when generating the names. So column name also should keep, let's say column name is first name, something like here. So here, first name is my column name, right? So automatically this will be converted into first underscore name. And table name will convert into, prio underscore user. So these are all, this is schema name, catalog name, table name, sequence name and everything. But see, we are not going to use these. We are not using these situations, but at least we will end up using physical table name and physical column name. How do you want to generate these two for now? So these situations, very tricky. I never used that situation. Even you can say, to do and some the column and return null or something.
Okay.
So let's just look at only these two things for now. Table name, how do you want to generate? Column name, how do you want to generate?
Okay.
So now, let's come back to here. So I have included how my table names to be generated using my customized naming strategy object now. So by here, the configuration is complete. Now, how to generate this now? So this is again Hibernate object, new schema, export this Hibernate specific class. And for this, you can see here, whatever the configuration object that I built, I am passing it to schema export. And then, how do you want to generate? For each line, at the end of the line, I want to keep, semicolon for every line that is generated in the SQL script. And where this output should go. Once you generate the output, where do you want to save? So I want to save at this location, source test resources. So now I'm going to create here new folder. Resources. So now once we run this class, Hibernate-schema, the specific file needs to be generated and should be saved in source test resources path. And you know how the format and execute what you want to execute. These are all also pretty standard. So if you want to know how each one is, you just go and it will download the source. So here it will explain you each one how it is generating, and let's see now. So this one. So this will tell you exactly how it is interpreting. There should be something. Is that documentation? It should give me the documentation ideally. Yes. Or else you can read the API. You just go to the Google. When you don't get it, go to Google. Hibernate schema export. So this one. So you can see this, right? This is a class, and you can see each one. What is execute? What it takes. See here. Generate the script. Generate the export. Just to drop. Just to create. You want to create only just create script, or you want to keep drop script, or how do you want to generate the SQL? So those options are here. See here. First one, the second one, I am creating just give me a create script. The first one, give me full script. So the only change in both of this is this line. So this one is true, false, false. Second one is true, false, false, true. The last argument true. This will Hibernate will take this argument and generates only create script. I'll show you how that is. So now this code, whatever the code that we have, this will generate two files into resource folder. One is full script, one is only create script. Now let's run and see how that generates. Okay, so refresh the folder. So let's talk about only create script, the second one, this one, how the file will have. So you can see the file name, whatever the file name that we have mentioned, the file name is generated with the same name. Now you can see here this one. So because I mentioned only generate the create script. So once I generated, I generated only create table structure. You see here prio underscore user, because our object is prio user. That's why you see the underscore. And the second one you see first name, last name. So that's also you can see here first N is capital, and the second one is last N is capital. That's why it is generated. Name says first underscore name, last underscore name. And the second one is varchar 50, 50 not null, right? So this one, how this is generated. So this is generated based on, we are mentioning it as a string. So Hibernate will convert into varchar. That's how my SQL database understands as a varchar. There is no string concept in MySQL. And the length is equal to, here I have mentioned 50. That's why you see the size of the column is 50. And here not null, because I have mentioned nullable false. It cannot be nullable. It cannot be nullable. That's why it generated not null. Let's say if I do, Now I'm removing all these things. Let's say I'm creating something like this. Now we come back here and just run again, run the class again. It's done. Yeah, it's done. Yeah. So now come back to the create script. Now you see why the So now the second column not null is gone, and the size is also by default MySQL supports 255 characters for every string type column, varchar type column. But you see the difference here. It is still not null. But in our entity, I have mentioned both as nullable columns. But when the SQL script is generated, it still keeps not null. Why? Because I am making this column as ID column. If I remove ID, so because ID columns cannot be nullable, now I remove the ID column. What is that? So now it says, you can see here, Hibernate, it generates no identifier specified for, you can see here, no identifier specified for entity. So it throws error because every entity should have an ID column. That's why it's showing, throwing an error. Now we will go and add an ID column just like this one. I showed you yesterday, right? So we are going to add the same ID column, and now because it is an ID column, if I don't give this line and without giving the name, let's say per se, I don't give this line, it still works. Now let's run the generation. Is that? Okay, now because we have added ID column, it is successful. Now if we come back and see here, first name, not null. These are all nullable now. And you see here, the column name is ID and additional blah, blah, blah. What does this mean? So because we are mentioning ID and column name as long. Long will be converted to num, big int in MySQL. And not null is coming here because it is an ID column. Because we have mentioned as a @ID identifier, automatically it will be not null column. And additional line is here, auto underscore increment. This will come because of this line. Because I am saying, based on this line, what I am saying is whenever a new trio user object is created, and I am saying generation type identity, meaning increment the number automatically, meaning whenever I create an ID user object, I don't set this value. Hibernate, let's say column value is 1 in the table, and when you're inserting second row, ID value will be automatically increment to the next number, that is 2. So each time a record is inserted into the table, the ID value will increase 1 by 1, 1, 1, 1, something like that. So if the max number is 100 in the user table, the next row when you insert, the value for ID will become 101. That's the meaning of auto increment. So now, because ID, here when it is generated, column name as ID, and you see here as a primary key is also ID, because we are making this column as an identifier. That's why the primary key will be automatically generated. Now,
can we specify any start value for the auto increment?
Yeah, you can do that. Auto increment, you can change the value, but I haven't done any time. I did very long time ago. I had checked. It's possible. Technically, you can make the ID start from whatever the number you wish.
Okay. Yeah.
But in a practical scenario, I never come across to do like that because we don't care about what is the number they insert. All I need to worry about what is my data. That's all.
Okay.
What is the automatical ID is generated? Nobody cares about. That's not business data.
Okay. Yeah.
Okay. So now, so I usually don't like just ID, something like this. The name is generated as an ID. So, if you like it, you can keep it. If you don't like it, you can change it. So that's what I usually do in most of my projects. ID. So I'm saying, keep my column name as ID. So what does it mean? If you don't like, if you like to keep as ID in your Java side, meaning in the Hibernate, wherever you want to fetch this object, you want to get ID or something like this, keep as a get ID. But in the database, you want to use a different name. Then you can give it. It's possible. You don't need to be strict that you have to only keep like this. So for this column, object side, you can keep first name, and the database side, I say first underscore name underscore value. Whatever the column that you like. If you want to distinguish columns between your Hibernate object and also in the database, it's possible. So now I do like this. Now we go back and let's generate again. Now you can see here. The column name is generated, whatever the value that I have given, and for this user ID also, both situations. Now you can customize your column names. So Hibernate will take care of that. So now I have created one entity with username, and let me generate the ID columns also. Okay. So the full entity class is created with the ID, first name and last name. Now let's go back and, I am removing the table name. You don't need to make anything like that. So now this is again my another class. So I have the address ID and the street name, just a simple two properties on here. Okay. So once we have the address, we have just the street name here. Now I'm going to map whatever the mapping, one-to-one mapping that we did yesterday. I'll do it in a minute. Let's not do now. I'll explain you first how these two tables can be keep in the configuration. So now I have created an additional one, bio address entity. I'm adding that entity class. So like this, any time when you add an entity, you just come here and add the new entity that is added into the configuration metadata sources. Now let's generate the script for this. So now, as you can see here. So I have user table, address table is also added now. So address ID, that's the increment column that I have given, just the street name and primary key, because address ID is an identifier. It generated primary key with address ID. So like this, you can create any number of entity objects, keep them in the Hibernate schema export configuration file, and it will generate the script based on your entity's definition. Now let's come back to build relation between these two entity objects, user and address. Now, so I'm saying one-to-one from user to the address one-to-one and join column based on the user ID. Let's see how general control shift.
The one-to-one for user ID should be in the address entity, right?
Oh, I mean, you can do anyway. I mean, I'll show you both sides how it generates.
Okay.
The mappings can be done however your business requirement is. I mean, there is no rule that you can do only one directional mapping. So I'll explain you how that works. So now here, this is unidirectional mapping, meaning from user to the address. I don't have any mapping in the address to the back to the user. So that is nothing but unidirectional mapping, meaning from class A to class B, but not from class B to class A. So one directional. So that is so that's what we did configure unidirectional mapping from prior user to address. Now let's see how this generates the SQL script. In case any of your configuration is bad, this file will throw an error. Did it generate a script? What is the change? It did not make any change. Did it make any change? No, right? Yeah, okay. So now you see here, nothing is generated. No foreign keys, nothing is generated. Ideally, Hibernate schema export should generate foreign keys because we are establishing one-to-one mapping. But you see here, nothing. That means something is wrong in our configuration. So here, the column name, I think that's what it is. Yeah. So what did I change? Just that from user, from this table to the address table. I'm mapping from user entity to an address entity. And what is the connect between these two objects? Connect me. Oh, I have given user table. Oh, something, this is also wrong. I have given wrong mapping. Prior address. I mean, I'm mapping here, right? User to user. That's not right. I'm mapping. I should map user to address.
Yeah.
So
That's what previously Abhi was talking about.
yeah. So now I did the wrong mapping. That's why. I mean, whenever you do any mistake that you with your entity definitions, so it will automatically reflect in your schema generation. So now you see here, I'm mapping to the address, and I'm keeping back to the same user ID column. Okay. Now let's generate this script again. So still you don't see any keys generated here. Any foreign key relation, nothing is established here. That means something wrong still. So address ID. Okay. So now you see, right, I made mistakes 2-3 times. When I made mistakes, I did not get this. So when you get this means you might be right. I mean, it's not 100% that you're right, and it generated it. So when it is generated, you need to see how do you want to establish the relation, how the script is generated. So now here what I'm doing is from user to the map from user to the address based on address ID column. So by using this, how it is generated, you can see here, address ID column is added on user table because I am keeping, this means keep address ID column on user table and establish relation with address ID column in prio address. That's the meaning of it. That's why you can see address ID column is added on the user table, and you see here relation is established. This is the MySQL foreign key constraint. You don't need to, we're not creating anything manually here. So for user table, add address ID as a foreign key with address table. So address ID in user and address tables will become a foreign key relation. So this is how we can generate, a unidirectional one-to-one mapping. So far we have seen only create schema. That's what you have seen here. So now let's say when you run something like this, you take this and go to the database. So just execute the script. I am not making any change. As is execute. See here. The lines you are seeing here, 2 lines are failed. I mean, I cannot create address or user because those tables are already available in database. These 2 tables are already available in database. That's why I cannot run the create script as is. So that's why I keep, whenever, second file. I'm generating the second file also from the Hibernate schema export, this one. So here, what I'm telling to Hibernate is, give me the complete script which include dropping of the stuff also. So based on the configuration entities that we have, these lines are extra generated in drop script. Okay, this is the only difference. So other one, Hibernate schema create, you get this one, and a regular schema with you see the additional these lines. So now what does means when just copy the whole thing and go to the database. So now what it does is it will drop user if exists, prio address if exists, everything, right? Drop all the. So if it is any foreign keys there, drop everything and regenerate. Meaning when you run this, it will drop everything on your schema and generates fresh tables on the schema so that you can use, so that at any given point of time, your entity configuration and the database table structure will be in sync. Now let's see. I'm trying to run and see what it will. Now you can see here. So everything is generated because when the tables are there, it dropped all other existing tables and it created whole schema or whole your schema structure again. So now you see here in the prior user, so now columns, whatever the column, user ID, first name, last name, address ID, whatever it is mentioned in this table, it's all generated. So that's how you can automatically generate your script based on your entities and use them directly on the database. So by doing this process, we will never make any data structure changes manually coming here. We always just generate a script and go and publish on MySQL database. Any questions?
So if we do any changes, add any column in the user table or add any column in the address table, it will generate an alter command and then do it, or how will that be?
Oh, it won't. That will not happen because alter script will never happen because Hibernate cannot keep track of what changes you made, what is previous, what is now. It's technically not possible for Hibernate to keep track. Now, let's say you have something like this schema. Now, you go back here and add. So let's say I'm adding a column, private string. Let's say I'm adding zip code. So this is an additional column that we have added here. It won't create alter script just because you added this line. It won't generate alter script to add this column onto this table. It won't. It cannot happen that way. All you can do is now come back to the Hibernate schema SQL, and you can see additional lines zip code. So this will be used only when you are developing your application in local and to run the test cases, database level test cases, to do all that sort of stuff. This will help. So once you do a release, let's say you did a release 1, and now you're making in the release 1, you have only street name. In the release 2, after once you production live, when you're adding this column in the second release, because you need to apply only zip code, you need to add only zip code column onto the address table, because you cannot drop everything just like that on production.
Right.
So in that situation, you have to create manual script. What is the? You need to create a difference between live release 1 and release 2, and those scripts only will run on production live database structure. This is more used in your local setups and to work on the new feature. I'll let you know. I mean, eventually you will get to know how you can write a patch script that can be deployed only on production.
Okay. And in few of the development environments, there will be a replica of the production database, right? So in that case also, we cannot drop the.
No, you cannot do that. So I mean, you cannot do that. So usually, what happens is on the development life cycle, we get the replica production copy, and then apply whatever the change patch script, and then run. This is more useful, when you are doing a test-driven development.
Okay.
Okay.
Yeah.
So now, similarly, I mean, what should I can explain? So I think I'll stop here. It's almost 40 minutes, right? So you practice all these things, and tomorrow I will explain you other 3 more relations. That is one-to-many, many-to-one, and many-to-many.
Okay, sure.
So with this, I'll stop for now, and you can ask me any questions.
Before you stop the recording, can you once show the configuration for generating the SQL in the console?
So this one?
No, I mean in the application.properties, you added a few of the properties, right? For
today I did not add anything.
No, it was not today. It was in the. It was sometime last week. Yeah, the property Hibernate show SQL.
Okay, yeah. This one, right? I can give you on the chat, meeting chat. Take it from there.
Okay, sure.